Okay, welcome everyone. Uh, Today we're going to discuss this energy efficiency and sustainable practices in MEPF. MEPF meaning mechanical, electrical, plumbing, fire protection. So these are usually the auxiliaries in our buildings, in our facilities, in our plants, and even in our homes and in industrial areas. So let's have our opening prayers. Amang banal, pinupuri ka namin at pinasasalamatan sa mga biyaya at sa tuloy-tuloy mong paggabay sa amin. Maraming salamat po sa pagkakataon na makapaglingkod sa aming mga kapatid at sa aming bayan. Sana pong maggawain ito ay magbibigay ng dagdag na kaalaman, kakayahan at kaunlaran ng bawat isa at para sa aming bayan. At sana po ay ilayo mo po kami sa mga sakit, lalong-lalo na itong coronavirus. Lahat pong ito ay aming tinataas sa iyo, dakilang Ama, sa pangalan ng iyong anak na si Jesus. Amen. Okay, here is my short resume. I'm Engineer William Jacinto Juan, professional electrical engineer, registered master plumber, an MEPF practitioner, engineer, and also I was once a methods analyst in my younger years. So here you see the companies and that I've worked with, no? And of course, some of them are also my advocacies, including in Rotary as well as in Pugad Lawin. So what is the Energy Efficiency and Conservation Act, or also known as Republic Act 11285? Okay, the Energy Efficiency and Conservation Act was signed by President Rodrigo Roa Duterte. That is Republic Act 11285, or the Energy Efficiency and Conservation Act, last April 12, 2019, to secure sufficiency and stability of the country's energy resources by promoting the development and utilization of efficient renewable energy technologies and systems. RA 11285 establishes a framework that will introduce fundamental policies on energy efficiency and conservation, including the promotion of efficient and judicious utilization of energy, increase in the utilization of energy, efficiency, and renewable energy technologies, and the delineation of the responsibilities among the national government agencies and private entities. The law creates the National Energy Efficiency and Conservation Plan, or NEECP, a national comprehensive framework that defines national targets and feasible strategies, as well as imposes regular monitoring and evaluation system. The Energy Efficiency and Conservation Act also includes or mandates the development and maintenance of a national energy efficiency and conservation database, or NEEZD, a centralized, comprehensive, and unified database on the application and use of energy efficient and renewable technologies and other relevant information that will discuss more on energy consumption. The Energy Efficiency and Conservation Act delegates the Department of Energy, DOE, as the lead agency responsible for the planning, formulation, development, implementation, enforcement, and monitoring of energy management policies and related energy efficiency conservation plans and programs. The Department of Energy is also tasked to develop a system of monitoring the implementation of the NEECP and maintain the NEECD. It also instructs the Energy Department to initiate and maintain collaborative efforts with the business sector, particularly the commercial and industrial, transport, and power sectors, to ensure compliance with the law and broaden and enhance their efficient utilization of energy. The law also seeks national awareness and advocacy campaign on energy efficiency and conservation that will likewise be done by the DOE in partnership with business, the academe, NGO or non-government organizations, and other sectors. The DOE is directed to provide annual reports to the Senate and to the House of Representatives with regards to the status of the implementation of the law at the national and local levels, cost-effectiveness outcomes, and energy and environmental impacts, among others. The law instructs all government agencies, including GOCCs or government-owned and controlled corporations, to ensure the efficient use of energy in their respective offices, facilities, transportation units, and in the discharge of their functions. It also creates an interagency energy efficiency and conservation committee that is tasked to provide strategic direction in the implementation of the government energy management program, a program that will produce or reduce monthly consumption of electricity and petroleum products by the government. The European Union access to the Sustainable Energy Program has estimated that a 10% improvement in efficiency will save the Philippines 55.5 billion, which translate to 1,680 annual savings in the monthly electricity bill of the average household. The World Bank has also reported that government energy efficiency projects can help the government save 3.4 billion per year. Okay, so this new act embodies the adoption of energy efficient practices, and my addition is sustainable engineering technologies on a nationwide basis. So we're not only talking of energy, that means electricity and fuel and other forms, but also technologies in engineering that will help reduce this consumption or the utilization of this energy. Okay, so here we have a flow diagram showing how an energy audit and measure could be done. No? So we have the passive energy efficiency and the active energy efficiency. Okay, and in the passive, you have to fix the basics, no? And in the active energy efficiency process, you optimize through automation and regulation. So if you use automation, then there is no need for manpower to be closely monitoring it, and it's you have a computer process that would automatically do the necessary regulation or control. Okay, and you do the monitoring, maintaining, and of course to improve as you go on. Okay, so what would be the examples of energy efficient practices or sustainable engineering technologies that we should consider for adoption in order to attain the general objectives of this new law, as well as to have sustainable systems in our midst? Okay, so let me start with this one. No, Basic energy saving system number 1. In electrical engineering, the use of higher voltage distribution system is always an advantage over using lower voltage distribution system. Say for example, in primary distribution of electricity, the distribution utilities like the Meralco or electric cooperatives all over the country, they can upgrade their existing distribution, like for example 13,200 or 13.2 kV system to the 23 kV system. Today there are 2 urban centers using the 23 kV system all over the Philippines, namely Metro Baguio and Benguet, which is Beneco or Benguet Electric Cooperative, and the Metro Cebu, which is Visayan Electric Company. So today these 2 centers, metro centers, are already in the 23 kV system. So it is already a more efficient system than the rest of the country, which most of the utilities around the country are still in the 13.2 kV system. Okay, urban centers like Davao City, Iloilo City, Bacolod, Batangas City, the 2 San Fernandos, meaning in Pampanga, and the one in La Union, Angeles City, Dagupan City, Boracay, and among others, are ripe for this upgrade. 2 distribution utilities are using the efficient 34.5 kV system or 34,500 volt system, namely the Meralco, which is for Metro Manila and includes areas of Rizal, Laguna, Quezon, Cavite, and Bulacan, and Cepalco, which is in Cagayan de Oro. So in the 34.5 kV, we see already it's a more efficient system than, of course, compared to the 23 kV, and much more compared to the 13.2 kV distribution or primary distribution system. Okay, number 2, 1.2, basic energy saving system number 2, use higher voltage distribution system. Again, when we're talking of distribution in the plant, in the building, or in the malls, then it is always better to adopt a higher voltage than let's say a lower voltage. So 460 volts secondary distribution is much better than 230 volts distribution system. And for high-rise buildings, 400 volts system is much better than the simple 230 volts distribution system. Okay, for the reasons of for those who are not electrical engineers, the reason is when you have a higher voltage, as compared 460 versus 230, the current values here in the higher voltages are much lesser, very much lesser than those in the 230 volts. It's the current here are valued at only 1/2 of the currents in the 230 volt system. In the 400 volt system, similarly, they are much lower than in the 230 volts. Of course, you may ask, how about between 460 and 400? Well, of course, in the 460, it's still higher. The current here are much lower than in a 400. But in the case of a high-rise building and malls, the usual system is much better with the 400 volt system, because in the 400 it's a 3-phase 4-wire system, and the line to neutral of this system is 230 volts. So that means therefore that there will be no need for a step down transformer to bring down the voltage for the lighting loads and the small power loads. Of course, the bigger loads like the big motors, the fire pumps, the elevator motors, the water pumps, the air conditioning, and all other loads in this kind of buildings, high-rise and big malls, will be at 400 volts. Okay. In 2.3, we mentioned about in residential area or projects, it's much better naman to have a 230 volt system than a 110 volt system. Definitely, because in the 110 volt system, the current will be much bigger. We always sometimes have clients, especially those who are coming from the America. Now, much of those Filipinos who are retiring from America would be bringing home to the Philippines their appliances in America, which are rated 110 volts. So if they do this, then you will be forced, the designer of the electrical system will be forced to provide a step-down transformer from 230 to 110. And again, those appliances at 110 will have will have a double current rating as those in the if you use 230 volt system. So again, not only will you have a higher a larger size of wire here when you use this as against this, no, but also in all of this, when you have use a lower voltage system, since the currents will be very much higher than in a higher voltage system, then it also follows that your efficiency, your what we call it the losses, no, the losses, the square of the current times the resistance of the circuits, I square R, or the current, the copper losses, we call it the copper losses, wiring losses, circuit losses, will be much larger, much bigger in the lower voltages in here, no? In the 460, very much smaller. Okay, so with the earlier slide, we're talking of in the 13.2, the 23 kV, and the 34.5 kV. In the 34.5 kV system, primary voltage, the losses here are much lower. Copper losses, no, line losses are much lower than in the 23 kV, and much more lower than in the 13.2 kV primary distribution system. Okay, I hope that is clear. Then we have here 1.3. Higher voltage allows the same amount of energy to be transmitted with less current. That's what I was discussing earlier, no? Smaller size of wire, and thus lesser copper losses. This is the square of the current times the resistance of the circuit. And lesser iron losses, no? The eddy current losses are much lower in the higher distribution voltages. Number 1.4. Although lower voltage is generally safer when it comes to electrical shock, okay, to a person, building electrical wires such as THHN, THWN, THW, TW, and so on, are insulated up to 600 volts. So that means therefore that even if you have a 460 volts or 400 volt system in lieu of a 230 volt system, your wires, this kind of wires, are very much safe to use in there. Okay, 1.5. Industrial plants for 60 volts distribution system is very much more efficient and cheaper than 230 volts. Of course, in here, when you're talking of providing lighting loads in this kind of plants, lighting loads and small power loads, there will be a need to provide a step-down transformer of that 460. But usually these transformers are very small, not very big. Okay, so there will still be savings in the primary feeders when you use 460 as against 230. I remember in the late 80s, as I was trying to design new expansion plans of the Coca-Cola bottlers, no? And like for example, we were supposed to I was supposed to add a new bottling line then, no? Say for example, Coca-Cola Antipolo. It already had if I remember it right, 5 lines, bottling lines, and we were supposed to add a 6th line, no, which was a high-speed line, and it needs a little bigger power capacity. So, but I cannot just upgrade or use 460 volts in there in the 6th line, because the balance of the plants are all still in the 220 or 230 volt system. So I had no choice but still to adapt the same 230 volt system in that in the existing part of the plant. So again, it was a 230 volts, and the transformer was so big, 2.5 MVA or 2500 kVA. The current was so high, with a 2500 kVA transformer and a 230 volt secondary voltage, your current is very high, and therefore it will entail a very, very big main circuit breaker. So that's the problem. So now when I was tasked to design the Santa Rosa plant, a new plant, in Santa Rosa, Laguna, I decided to suggest using 460 volts instead of the 230 volts. Okay, so the project manager then asked me why would I change the system from 230 to 460. Then I told him there will be a lot of savings when we use 460. First, we will have smaller size of feeder wires. We will have smaller sizes of circuit breakers, because our voltage is 460 volts. So in the long run, there will be a lot of savings. So the project manager then agreed with me. So in new plants of the Coca-Cola, starting with the Santa Rosa plant, we already use 460 volts. And the next one was Coca-Cola Mekawayan. It's also a new plant. It's also 460 volts. And there's another plant in Mindanao, the new plant in Cagayan de Oro. So it was then also used. We also use their 460 volts. No, but the rest of the balance of the plants all over, because Coca-Cola is over 22 plants nationwide. So the small, the old plants, no, still have the 230 volt system. It's very difficult to upgrade an existing plant to just simply upgrade it to a higher voltage, because the motors that you use there are already are rated 230 volts. The wires is no problem. You can reuse them because you're going to use a higher voltage, so the currents will become smaller. But you'll have problems with the magnetic controllers. The magnetic controllers are rated 230 volts. So when you upgrade it to 460 volts, there will be a need to change many of the control transformers and the coils, the holding coils of the magnetic stars. So there's a lot of work to do. But of course, maybe there should be a need to evaluate what would be the cost of upgrading these systems from a 230 volts to a 460 volt system versus the savings of the plants. Definitely, like I said, the I squared R will become much, much lower. Okay. For high-rise buildings, my recommendation is to use 400 volts line to line and 230 volts line to neutral. Okay. We started in 2074 the design of several high-rise buildings for the Avida. Avida Tower San Lazaro was the first among the first to use this with multiple secondary metering, because there were other projects already that used this 400 volts, but it was on a primary metering basis. The Avida San Lazaro 22-story buildings, 5 towers, 22-story buildings, was the first to use multiple secondary metering, where the secondary meterings were located in each of the floor, from the ground to the 22nd floor. So well, of course, at that time we had a little difficulty having it approved by the Meralco design, because the Meralco wanted all the meters to be located at the ground floor. But we were able to convince them that with the use of a bus duct and plug in main breakers on its floor, and it will be a lot of a more efficient system when we use a multiple secondary metering. And of course, they were provided with a mother meter to make sure that pilferage will not just happen. Okay, so 1.7, 110 or 120 volts as much as possible should be avoided. Like I said, this one is a very inefficient distribution. In America, they use this because they have, they have snow, so a lot of water. So safety is their concern there. No, but I think America now is trying to upgrade to the 230 volt system. Here is a slide that shows us several other facets of a building which we can do a lot of savings, especially when we adopt building automation system. So building automation, we use a central computer to monitor all of this, the functioning of all of this. So therefore, with input-output devices installed in the control of this equipment and devices all over the buildings, you could end up with a more efficient process of work in the building. Okay, so let's have a break.